Okay guys, we can start today's session. So in the previous sessions, if you remember, like we have been discussing about the basics of ROS 2. Okay, we have been following the basic tutorial that is mentioned in the ROS 2 tutorials. ROS 2 tutorial documentation. So if you miss the class, I think you can just go through it. It's not a big thing because if you already know ROS 1, you can easily understand what is happening in ROS 2. So we have covered all these topics, basic topics, and I think we completed up to this. And today, as I commented, these are the topics that I'm planning. Okay, so you know about ROS actions, right? So how we can implement the ROS action in ROS 2. Okay, and like if you remember, there is an option to create our own custom messages and service and action. Okay, so for example, if you want to send a custom message, okay, like your own message, like examples for standard messages are like string, then image. There are a lot of standard messages available, right? But in case if you want to create custom messages in ROS 2, how to do that? I think we already done that in ROS 1, but how to do it in ROS 2? Okay, so again we are using the official tutorial, and we will be seeing how the ROS 2 launch file work. Okay, not in detail, but I will explain some more concept. Then in our last class we have talked about ROS 2 parameters, and we will see how to monitor ROS 2 parameter like from a callback. Okay, so the problem with the ROS 1 parameters was it was static, meaning once we set the parameter, we have to reread the parameter. We have to read the parameter again. Okay, but in case of ROS 2, there is a new option, which is like if you change the parameter, immediately there will be a callback we will be getting, like service or topic. There is a callback will be triggering, and you can make use of that parameter and change based on the parameter change. Okay, so so these are the topics that I am planning to cover. So let's start with the ROS 2 action. ROS 2 action. Okay, ROS 2 action. Okay, so you can take the link. You can see here, writing an action server and client in C++, writing action server and client in Python. Okay, so these are the two links that we are going to take, and as I mentioned in the last class, obviously action implementation, ROS action implementation is difficult somehow. Okay, but why it is difficult? Because there are a lot of code, and there are a lot of API that we are using, so it will be, it will not very easy to understand. Okay, but my plan is that not to teach each line of code, okay, but to understand what is going on in the code, just the logic part. Okay, that is what the important thing from my opinion. The code you will get, the template code and all, you will get it from anywhere. Okay, but the logic, how we can implement it, that is what important. So first of all, if you are not aware of the action, you can see this is how the action work. We can compare with the ROS service. Like there is a if we check the ROS service, we have a ROS service server and service client. Very similar to that, in ROS action, we have ROS action server and action client. Okay, so when we compare with ROS service is working on like a request response kind of method. So we will be requesting for some I mean some features, like for example, if we want to add two numbers, we can call a service, and the service server will be adding two numbers and send to the client. So this is how the service works. In action, it is somewhat advanced compared to a service. So how it is advanced? Like we can send a request to the server, and server will be executing that service, okay, or the request. And there are some conditions that can happen. For example, if the action that is server doing, like the request that we have sent to the server, is taking long time to process, okay, long time to process, maybe like 5 to 10 minutes, imagine. Then if you are working on ROS service, the client will be stuck there, okay, client will be stuck there. It is waiting for the response, because in service we will get the response only after completion of the processing. But in action, there is a difference. Action is like you can give a request, okay, and maybe you can wait for some time, maybe for 10 seconds or 15 seconds. And if the action processing or the request processing is not finished within some time, what you can do is you can cancel it, okay. And also another advantage that we are getting with the action is that we will get the feedback of the operation. So if the action server is like counting from 1 to 10,000, you can able to get the feedback of that process in the client. Okay, that is actually very good, right? Because you get to know where is the task now. Okay, if the counting is at 1,000, then you get to know there is 9,000 remaining. Okay, so this is the flexibility that action gives. And then after completing the service successfully, if they can able to complete, if the server can able to complete the request successfully, then it will be giving the final service result. Okay, so these are the things, guys. These are the main things that action provide to us. Okay, and we are going to see how to implement this in ROS 2. Okay, how to implement these kind of things, like we have to create an action server, then action client, then we have to the client has to send a request to the server, and then when the server receives the request, it has to publish the feedback, and the result has to be sent. All these things we will be seeing. Okay, so this is a concept. So I just mentioned before starting it. So let's start with the programming side. Okay, so similar to other concept, this is also like the tutorial also showing an example first in C++ and in then in Python. You can see it's a very lengthy code, but if you understand the logic, it's very easy. Okay, so don't be confused with the lines of code and all. The first thing that I'm going to do is I'm just following this tutorial and going to run this. Okay, so you can check how to execute this tutorial. Okay, so I'm just following this. Okay, so first the tutorial saying to create a package. Okay, to create a package, for keeping this service. Okay, so let me create a new package. Creating a package in ROS2 is very easy. ROS2 package is the command. Okay, 1 second. Okay, so I have a workspace called ROS2 workspace. Okay, now I'm just creating a new package called let me just create first 1 second. Okay, yeah, 1 second guys, let me check something. There is a small mistake, I guess, in the tutorial. Yeah, I think that will be okay. Yeah, so first is creating the package, and what I'm doing is I'm mentioning the dependencies. Okay, dependencies. Then there is a sample service available in ROS2. Sample service means a dummy service. Okay, for learning purpose. So the package name is action tutorials. Okay, action tutorial interface. So we have to mention that package as a dependency here, because we are using this dummy action for this code. Okay, and then RCL CPP, that is like we are working on the C++, right? So RCL CPP as the dependency, and then RCL CPP action, RCL CPP components. Okay, so maybe I can copy paste, that will be better. So this is what the entire command is. Dependencies are action tutorial, RCL CPP, RCL CPP actions, RCL CPP components, and this is the name of the package. The name of the package is action tutorial. There is a problem. I need to execute it from the SRC folder, like we have done in the ROS1. Okay, so if you do that, then you can see this package. Okay, action tutorial CPP. Okay, and we can simply go into inside the package. So if you check it, 1 second. In the package.xml, you can see the dependency here, and there is a thing called RCL CPP component. Okay, so that is again a new concept. Okay, we can write the nodes as a component in ROS2, so that I will explain later. So we have just created an empty package, and we have the CMake package.xml everything. So the next thing is fast. Next thing is obviously like we can simply copy paste the first code, which is the action server. Okay, example action server. So we have to keep it where? In the SRC folder we have to keep it. So I'm just opening the gedit, and then created a new file, and then this is the server code. Okay, so this is the action server code, and I mean it's too big, but don't worry, I can explain it. Once you get the idea, then it is super easy. Okay, so first I'm trying to build it. Okay, so I got the server, so you can see the server here, and now we need the client. Okay, so the client code is also mentioned in the tutorial. So I'm just 1 second. 1 second, guys. Yeah, the client code is here. Gedit. One second. .client.cpp. So this is the client code. Again, a big chunk of code. And what's next? The next is to compile it. Okay, so that is the next part. So let's compile the code. So this is a CPP code that you know, and in order to compile the code, you have to edit the CMake list. So this is the default CMake list, and you have to add set of lines to compile it. Okay. So let me just copy paste the line to compile the action server first. One second. So again, this CMake line will be, I mean, it seems difficult for you because it's not like a regular thing that we have seen earlier. Okay, add library, action server it is there. And now for the action client, I will do the explanation after making sure the package works fine. Okay, so this is for compiling the server and this is for the client. Okay, so we have done everything, and yeah, now it's a time for callcon build. Okay, I think that is enough. So let's start the callcon build, which is the command to build the packages. Okay, so it is building. Seems like, let me see, our package is the package. Yeah, I think the package is getting compiled. Let me just check. Yeah, it is checking other packages as well. Yeah, there is an error that we are getting. It is like action tutorial visibility.h. That we can check it, guys. We can check whether that is really required. One second. Yeah, got it. Yeah, so it's a simple thing. As you know, the rows 2 will be, I mean, it can work on Ubuntu, Windows, Mac OS, all the things. So what they did was they created a header file. Okay, they created a header file. So you can use this project in Windows, then Linux or Mac. Okay, so for that, what they did was they created a header file. Okay, so if you have a package, C++ package, you can keep the source file, that is CPP file, inside the src folder, and header file include this folder. Okay, hash include, then the package name. So here we have to create a header file. Okay, they have already given the header file, which is called visibility control. Okay, I will explain it. Okay, so visibility control is this. So it's basically some if-def condition. It's basically checking if you're working with Windows, if you're working with Linux, then based on that, it will be changing some visibility flag. Okay, it's basically for Windows actually. Okay, so this header file should be there. So that's what they are, I mean, this error is actually shown. Okay, so this header file is inside our package. So let's run the callcon build.
Sir, excuse me.
Yeah. Tell me.
Sir, why you use this visibility? If I'm using to is I also need this
No, no,
visibility.
no. Actually, this is just for a demonstration. So, like, if you are working on Windows, then only this will be this will matter much. Okay, so you can check the header file. Is you can see if it is Win32, then you have to do some exporting. Okay, so that is why we need to add. This is not required, I think, for Linux, but I am just following the tutorial. Okay,
But
and
sir, your system is I think Linux, no?
yeah, but this header file is checking whether we are working on Windows or Linux. If it is Linux, then we have to set some parameters like visibility to hidden or something like that, this one. So you can see this condition, right?
Yes.
So GNU means the compiler is like this version, then we have to do this. So it's like a check whether we are working on Windows or Linux, and if it is Windows, we have to export or define um, some values. Then only we can build ROS action. Okay. So that is the only purpose of this, but it is required to build it. So currently you can see it is building properly, and the visibility thing is required. I mean, both in Windows and Linux it is required, but if you are working on Linux, I think there we can manually add 1 or 2 lines to fix this. Okay, so maybe while explaining the code, I can mention this. Okay. So after putting the visibility header file, we have done the Qualcomm build, which build the package, and now we can start the action client and action server. So let me start the action server first. So in ROS2 there is no ROS master or something. We can simply run it. Just run using ROS2 run command. So it's like the action server seems like running, and this is action client. Okay, basically it is for finding the Fibonacci series. So you can find like it actually send Fibonacci for order turn. Then you can see it is getting the feedback. Okay, so like the client actually sent 10, server received the order, and then the Fibonacci series is actually calculating. So in each calculation you can see the feedback that is received, and this is the final one. Okay, this is the final one, and these things that we are seeing is the feedback, and this is the final result. Okay, so from the feedback we will get an exact idea like where is the, I mean, in which position is the server currently. Okay, so we can execute again. So you can see here the Fibonacci Fibonacci action server and action client. Server is computing the Fibonacci series, client is receiving it. Client is actually sending the order means like maybe I can do a simple modification in the client side. If I'm changing the order into maybe 20, and after modification I need to do the Qualcomm build, and then we can see how it goes. Okay, it will take some time. because there are a lot of packages in the repository, in the workspace. So I'm running the server and the client. So you can see here sending goal is 20 and it's keep on computing. Okay, you can see the final result is here. Okay, so now let's start with the code explanation, how the code works. Okay, so that is the next thing. So we have the client and server, so let's open it. We have the client here and the server here. Okay, so in a first look, I'm just scrolling, you feel like, it's a very complex code, right? Okay, but actually it's not. Okay, actually it's not. So basically the action server, this code is having a node implementation. You can see the class, okay, it's called Fibonacci action server, which is inherited from the node class. Okay, and what it is having is, it's basically having three things. Okay, so what are the three things in the ROS action? It has to receive a goal, it has to publish the feedback, and it has to send the result. Okay, so these three things are implemented inside the class. So if you check this class, okay, which is actually keeping in a namespace called action tutorial CPP. Okay, entire code is actually inside the action that I will explain, but just check this. Okay, so if you check this class, the class length is up to this. So basically this node is inside this class. Okay, so this form of nodes are called ROS2 components. Okay, this is again a new method of writing nodes in the form of like plugins. So this will looks like kind of plugin. Representation looks like kind of plugin. So it doesn't have any int main like our normal code, and it will be like an library. Okay, so if you work with ROS plugins, the representation is almost similar to the ROS plugin. Okay, so what happening is that inside this class we are implementing the server thing. Okay, so what are the server thing? Once we get the goal, how to handle it. Once we get the cancellation, how to handle it, and then how to publish the feedback. Okay, all these things. Okay, so let's see how it works. So first is like, don't look at the meaning of each lines, because that will confuse you. So this line is what we are creating the server. Okay, so what happening is that when we execute the action server, okay, action server, and if you check ROS2 action list, okay, ROS2 action list, you can see Fibonacci. Okay, this is the action that is currently serving by this action server. Got it? And that is what seeing here. And then there are some callbacks. Okay, so what are the purpose of the callback? So you can check handle goal. Okay, handle goal is there, then handle cancel, okay, that is there, and handle accepted, okay, that is also there. So what is happening is that, so when we send send a goal to the server, first it will be going to the handle goal callback. Okay, handle goal callback, and you can see here received goal. Once we send the goal, you can see this message, received goal, request with order 20. Okay, so that is what this function is about, or this callback is about. So what is the first thing? When we received a goal from the client, first it will be going to this callback, and then it will be returning with accept and execute flag. Okay, this value. So meaning after getting the goal, there is an option to decide, like if you return this accept and execute, then only the action server will execute the goal. Okay, then only it will be executing. So once the handle goal is completed, okay, then the handle accepted callback will be calling, and what that does is that it will run the execute function in a thread, meaning it will run the main function. What is the main function? Main function means the main function of this code. Okay, that is the biggest function of this code, which is executing the goal. Okay, so once we receive the goal, it will be checking the goal, and then it will returning with accept and execute. After this callback, the program will go to another callback called handle accepted. So once handle is accepted, it will be running the goal. Okay, running the goal, which is this execute function. Okay, so that is what it's shown here. It will be running the execute function in a separate thread. So what is happening in the execute thread? The execute thread is processing the Fibonacci series. Okay, so this function will be getting the goal, then publishing the feedback. You can see here it can publish the feedback. Okay, and then whenever the goal result is succeeded, it will be publishing the final result. If the goal is cancelled, then it will be going to the this callback, cancel response. Okay, so these set of processing is happening inside an action server. Like I can say it again. Once we get the goal position, we will, the action server goes to a callback, and then it will be returning with the operation, whether it has to accept the goal and execute, or that is deciding by the handle goal. Okay, after getting the goal, then what? Then it will be going to handle accepted. Okay, handle accepted, and then that handle accepted will start a execute thread. Okay, thread it will be executing, and the execute function is what the main function of the server, which is like getting the goal, then computing the computing Fibonacci series, then publishing the feedback, then if there is any cancellation, then it will be responding to that. Okay, so that is how the code works, guys. Okay, if you have any question in the logic, let me know. Okay, so then I can discuss. Okay, just the logic that I am talking about. That is what the main part. Okay, so let me see if you have any any doubts.
Yes, sir. Yeah, actually, the Fibonacci series, the logic is in the middle, right?
Yeah, in the execute function.
In the execute function.
Yeah.
Actually, the screen is, I think, going up, down times. Can you, for example, minimize everything? And for example, the callback first go to this, second callback goes to the main,
Yeah.
third callback goes to me like that. You can explain like that, please.
Yeah, I think that's what I explained, but maybe with the example I can show you. Maybe.
Thank you, sir.
Yeah. So if I'm running this server and client, you can check the check. One second. Yeah, this is having everything, I guess. Yeah. So just check the messages. Like when the client send the goal, the server is printing received goal request with the order 20. Okay. So where we can find that message? Here. Okay. Which is handle goal. Okay. Handle goal. Now, after that, it will be going to the handle accepted. Okay, maybe what I can do is I can print something. Okay, print something here, so you will get a clarity. Maybe in the handle accepted I can request to handle accepted. Okay, so let me just close it and then do the callcon build, and then we can execute again, so you will get an idea. Okay, yeah. So yeah, so if I'm running it, and if I'm running the client, you can see oh wait, just a second, I think that is actually missed. Received request to handle accepted. One second. Oh wait, callcon build. That should be printed, but I can't able to see it. But let me just build it again. Yeah. Let me start the server. Now action client. Somehow it is not printing. I need to check it, but the plan was to to get an idea, like, so when we get the goal, it will be printing the received goal with order, and when it is accepted, it will be going to this function. Okay, so it will be printing received request to handle. I have a doubt because the action tutorial CPP, it is actually there in the system. Yeah, it's already there in the ROS installation. Okay, so we can just check which executable is executing when we run this I mean run this node. Okay, so from that you will yeah, so this is the problem. See, so when you execute this node, no, 1 second. Yeah, when you execute this node, the same package is available in the ROS installation package. Okay, because they included this tutorial package along with the installation. So the problem is that when you do the action tutorial example, it is executing from here. That's why we can't able to see the change. So what I will do is I will be sourcing the ROS to workspace again. So this is how we can source, and then I am doing the Qualcomm CD action tutorial. So let's see, it's changing the path. Unfortunately, it's not changing. Okay, but that is the problem, guys. Like if you have the same package name, then make sure that is not installed or not. Otherwise, the installed folder package will be running. Okay, so if I'm doing the Qualcomm CD, which is equal to the ROS CD, I'm getting the package from the installed folder. Okay, I'm just closing everything to try from a new terminal to check the results are the same or not. Qualcomm CD. Yeah. Okay, so it's still there is a problem. Source ROS to workspace, install, setup.
So sir, we cannot remove the file in the shared directory.
Actually, that is installed using apt package manager. Okay.
Yes.
Yeah. So it's not. I mean, it's not safe to install it. Remove it, because it may uninstall some other ROS packages. Okay, because it's like, for example, maybe I can try, but I'm not sure it will install individually. That is the problem. It has some dependency. Let me check. Action tutorial. Okay, that is the package name. Okay, action tutorials. Yeah, so here is a package, and if I am just removing it, see, it will be removing ROS humble desktop and ROS humble desktop full. That means it will remove entire ROS. Okay, so better to not do that. Instead of that, like if you can overlay the workspace like this, it should work, but unfortunately it's not working. I need to check, but let me run it again to show you the one technique is to change the package name. So that is the easiest method. So for example, just go to the package which is action tutorial CPP, right? So now what you have to do is just change to action CPP1. Okay, and change the name in CMake as well. Okay, and also find any reference. Okay, any reference. Okay, fine. Okay, so we can just try it whether it work or not. Okay, ROS to workspace, and I'm just removing the build install log. Okay, and then Qualcomm build.
Sir, mostly it will be better if we just Qualcomm that specific package.
Yeah, that's also. I was lazy enough to mention the package. That's why I'm just did this. Anyway, like it is building the, yeah, maybe next time I can do that. Anyway, so I think it will take some time. Let me see the name change is working okay. Um, yeah, it will take some time.
Sir, in between some question.
Yeah.
So, sir, what do you recommend? ROS 2 is better or ROS 1?
Yeah, so it is purely depend on the application. Meaning like some applications may not require I mean like if it is a prototype or something that doesn't require much security or like um, new features that ROS 2 gives, then ROS 1 is okay. I mean, the implementation wise, I'm still working. Some projects are in ROS 1. My projects, some of the projects are in ROS 1. So it clearly depends on the application and also the client requirement. Or like if you have a professor, if they are saying like you have to do it in ROS 2, then you have to. So if I am doing something, if I am finding some ROS 1 based package that is already available, maybe I will use that because if I want to work with ROS 2, I need to re-implement the same package in ROS 2 and work. Okay, so it is time consuming. And I have done like 4 or 5 projects in ROS 2 because they the client wants to stick on to ROS 2 somehow. So and also based on the application, like if it is a product, if you're working on a product, then I will prefer you to stick on to ROS 2 because that's why ROS 2 design, the main purpose. I think you already know why we need to switch to ROS 1 to ROS 2. Mainly the product thing, like we can add the security layer and then real-time communication. All these things we can able to get it. So yeah, so that is my answer, Kasim. Yeah, depends actually.
Thank you, sir.
Yeah, still we are like migrating. Like I'm not very happy with the ROS 2. I mean, there are still a lot of improvement need to make and also a lot of bug fixes. Not stable as ROS 1, that is for sure. So yeah, I'm just learning it and then I'm doing it, but I'm not happy as ROS 1. Yeah.
Actually, sir, I started to write a book on ROS 2.
Yeah. I mean, the problem with ROS 2 is that the versions are keep on changing very fast, like in
Yes,
3 years.
fast.
Yeah, and then there is no point in using the old version as well because they are not maintaining, and also like what there are bugs as well. So if we check the latest version, there are new features. Yeah, so I am also confused. Like in case of ROS 1, even if you work in ROS Indigo, no, it may work with maybe Kinetic and Melodic and even Noetic. But in case of ROS 2, some packages will work with all the version, but there are a lot of changes happening. So, I mean, it's very difficult to make the packages compatible with these old versions. But maybe we can do that for creating educational material. Maybe we can do that, but for complex projects and all, I think there will be because today I was working on a MoveIt based project. The problem happened was I have implemented it in ROS 2 Humble, and the client actually tested in ROS 2 Iron, okay, which is the latest one. So it is not working, and there are some bugs as well. I mean, it's compiling, but it's not properly working. So like yeah, that's what I'm saying. Like there can be changes and some bugs as well. So yeah, that is a problem. Anyway, yeah. So let's
Thank you, sir.
So let's execute the row CPP1 that we have created. Let's see it's working or not. Initially it's saying it's not finding the package. Let me see. Fibonacci action server. Yeah, seems like working. And now the rows to run action tutorial, then CPP1, then Fibonacci. Yeah, better will be like changing the name like this. Oh, okay. Yeah, so now I think it is working. You can see here received goal request with order 20, then received request to handle accepted, then it started executing the goal. Okay, which is what we are seeing here. Fibonacci server, yeah, handle accepted, then it started working. So when it started working, you can see executing the goal, that is the first message here. Okay, then it went to a for loop. Okay, for loop for like computing the Fibonacci. So that's what you can see here. Executing goal, then publishing the feedback. Okay, which is we can see here, publishing the feedback, and it's actually executing the Fibonacci thing. Okay, and then if there is any cancellation, okay, you can cancel it. If there is any cancellation, then this will be exiting, the for loop will be exiting. If this for loop completed, that means the task is completed and the final goal, they send the final goal. So this is what happening in the server side, and in the client side you can see, I mean, there is not that much thing, but the main purpose is to send the goal, then wait for the feedback and the result. That is what the client does. Okay, again the same format. Inside the class is inheriting from the node class. Okay, and then this is the client thing. Okay, so the client is connecting to the Fibonacci action, and then I think, yeah, so the client is actually sending the goal in a 500 millisecond. This is a timer actually. So sending goal is here. Okay, so here this is a sending goal, and then based on the, I think it's like a recursion, like it's actually sending the goal, and then what happening is that it is waiting for the feedback and also the result. That is what we are seeing here. We are creating some callbacks. You can see here, these are the callbacks, like whenever we get the feedback, this callback will be calling. So you can see the messages from the callback here. Next number in the sequence received. Okay, so that is happening in the feedback callback. And if we get the final result, this is the final result callback. So if it is succeeded, it will be saying like it is succeeded, result received, and it will be printing. But there are other conditions, like the goal can be aborted, goal was cancelled. All these things will be handled by the result callback. Okay, so and if the goal is accepted, I mean, initially when we send a goal is accepted, then goal accepted by the server, waiting for the result. That is what we are seeing here. Okay, sending goal, then goal accepted by the server, waiting for the server. Okay, so the goal that we have sent was 20, and then in the feedback loop you can see we are keep on getting the sequence. Okay, we are keep on getting the sequence one by one. Okay, so again almost the same, like from here we are sending the thing and then so here there is a thing that you have to notice. I was also thinking why they put a timer here. So the idea is that the timer will be first calling this function called send goal, and inside that they are cancelling that timer. Okay, so simply this function will be executed at once. Okay, so they are cancelling the timer and then they are waiting for the server, action server. So if the action server is not available, then it will be shutting down. If it is available, then it will be sending the goal. Sending the goal is happening. Yeah, sending the goal. Okay, so that is what happening in this line of code. Okay, so I can split the lines for you to get a better understanding. These are the callbacks to handle different scenario, and this is where we are sending the or calling the server. Async send goal is the function in the client that we are using to send the code. Okay, yes, so this is a abstract overview of the server and client. Okay, action server and client. Okay, I think we took a lot of time to discuss this, so today I think we can close with this topic. Okay, and tomorrow I think we can continue with the rest of the topics with this Python implementation, then custom messages. I think that will not take that much of time, but action obviously takes some time to understand and explain. Okay, so that's it, guys. I think now you can ask question if you want, if you have any doubts or something, because we handle a big topic which is action. And let me know if you have any question in the logic. If you understand how it is working, that is fine. Otherwise you can ask me, and yeah, that's it. Let me know if you have any question.
Thank you, sir. I understand all the points.
Yep.
Thank you.
Yep. Okay, then I think then we can conclude for today's session. Okay, so tomorrow we will be discussing the rest of the part. Okay, hope we can finish it soon. Okay then, thanks for attending. Bye everyone.